Alrighty, now for the last practice problem, number 3, we're going to find a solution of the IVP, the initial value problem, given an ODE that reads y prime plus 4y is equal to cosine t. So this here, which I'm boxing, I'm going to label that our ODE, right? That's the backbone of our problem here. And then this thing, this y of 0 is equal to -1. This is called our initial condition, right? That will allow us to pinpoint a particular solution. Okay, and then this thing here that we're already given, because we don't know how to solve for them just yet, this is our general solution, okay? So I'll just write general solution by it, okay? Just as a reminder, we're going to, so the first thing we're going to do is find a solution of the initial value problem. So by solution, they mean a particular solution. So what we're going to do first is find this particular solution, and then we'll deal with the rest of the problem, okay? So in order to find our particular solution, all we have to do is take our general solution, and we're going to apply to it the initial condition, right? So if we plug in 0 here, if we say y of 0, this should be equal to -1. And this 0 here means that we're plugging in t is equal to 0 now. So we're going to take our general solution here, and wherever we see a t, we're going to plug in a 0. So 4 over 17 cosine of 0. That's going to be plus 1 over 17 sine of 0 plus c times e to the -4 times 0, right? So this is e to the 0, which makes it a 1. Okay, this sine 0, that's going to equal 0, so that term will go away, and we're left with something like this. So now we can use this equation here, which again I'm boxing, to figure out what is our specific c, our constant here, okay? And cosine 0 is just 1. So that's all we have to deal with. So we have -1 is equal to 4 over 17. And this is a 0, and then we have plus c. So in order to find c, we just subtract 4 over 17 on both sides. So we get -17 over 17 minus a 4 over 17. And this is going to be equal to a -21 over 17. Okay? So that's our c. That's our specific c, our constant here. So in order to find our particular solution, we just plug that back into this spot here for our c. Okay? So now we have y of t is equal to 4 over 17 cosine t. So we're just going to copy down our entire general solution, and the only change we're going to make to it is by plugging in this constant c, and we're going to plug in a specific number for it, the one that we just found. So -21 over 17 is going there, and we have our e to the -4t here. Okay? And this right here that I'm boxing finally is going to be, this is our particular solution, okay? So I'll just label it particular solution. All right, so that was the first part of our problem. And now on the next part, or on the next slide, I'll do the whole sketching this thing. I'll just sketch it for us. And then our initial condition, and we're going to find the interval of existence, okay? Alrighty, so here again, I'll write what we got. So our particular solution is 4 over 17 cosine t plus 1 over 17 sine t minus 21 over 17 times e to the -4t. Okay, so this is our particular solution. And graphically, what this looks like is basically something that looks like, it resembles kind of like an upside down exponential graph. So something like this a little bit, except for because of this cosine and sine term, it goes a little bit sinusoidal, the term is. It just means like it goes up and down, it oscillates a little bit. So it'll look something like that, and it actually looks something like this. It goes up, comes down, up, down, and continues on, okay? And this graph is graphing y against t, okay? So our y of t and our t are here. And then, so this is the graph of, like a sketch of what our graph actually looks like. And then as for our initial condition, remember that was y of 0 is equal to -1, right? And that would be right here, okay? So this is our initial condition. That's our point 0, comma, -1. Alrighty, and then the last thing is finding out our interval of existence, right? So if we look at our function here, the formula for our function, cosine and sine are continuous on all real numbers, right? There's no place where they could be discontinuous, okay? And then this thing here, even though it can be written as like -21 over 17, and then we could write this on the bottom, e to the 4t. Even if t is 0, our e is still going to, this term down here is going to equal a 1. So there's no way that the denominator could equal 0, so there's no way our function could be undefined, which means that our interval of existence is going to be -infinity all the way up to infinity. This is also known as all of the real numbers, right? So t can be anything that we want it to be. Alrighty? Okay, that wraps up our practice problems video for section 2.1. I hope that helps, and good luck on your homework.